Good morning. We need to prove that this left hand side is equal to this right hand side. So let's start with the solution. On the left hand side we are having 1 plus iota, that is your complex number. So let's consider this 1 plus iota to be equal to the complex number, and let me take this complex number in the polar format, that is r e the power iota theta. Similarly, for 1 minus iota we can take the complex number, just replace iota with minus iota, that is r e the power minus iota theta. So this is how we are going to start. So let's consider 1 plus iota to be equal to r e the power iota theta, and if I use the Euler's formula over here, e the power iota theta means cos of theta plus iota sine of theta, right? Because I need to get the value of theta and r, let's compare the real and imaginary parts. So on comparing the real part, I get 1 equal to r cos of theta. On comparing the imaginary part, I get 1 equal to r sine of theta. If I square both the sides and add these two equations, I will be getting 2 equal to r square cos square theta plus r square sine square theta. I hope this step is clear. First square both the sides of both these equations and then add these two equations after squaring, right? So from here we get, if I take r square outside, we have cos square theta plus sine square theta, which is your identity, that is equal to 1. So we have r square to be equal to 2, or r is equal to square root 2. So we have found the value of r to be square root 2. To get the value of theta, we can put the value of r in any these two equations. So let me use 1 equal to r cos of theta. And now putting the value of r over here, this is square root 2 cos of theta, and cos of theta is 1 divided by square root 2. When the cosine is 1 by root 2, at what angle? At cos of pi by 4, right? And when comparing the angles, we get theta to be pi by 4. So we have got both the values of r and theta, and now we are going to put these two values over. Let me mark this equation as 1, so that we can get the value of 1 plus iota, right? So from equation 1, we have 1 plus iota to be equal to r cos of theta plus iota sine of theta, right? So this is, I put the value of r over here, and cos of pi by 4 plus iota sine of pi by 4. Reason, we have got the value of theta to be pi by 4 and r to be equal to square root 2. So this is 1 plus iota. Similarly, we can also find 1 minus iota to be equal to square root 2. Replace iota with negative iota. This is minus iota sine of pi by 4. And now we are going to find this left hand side complete with powers n, right? And add these two values with powers n. Okay, so 1 plus iota power n, what it is equal to? It is square root to the power n, right? And cos of pi by 4 plus iota sine of pi by 4 the power n. Using the de Moivre's theorem, this becomes 2 the power n by 2, and now using the de Moivre's theorem, we get cos of n pi by 4, this power is multiplied with this angle, plus iota sine n pi by 4. Similarly, 1 minus iota the power n becomes 2 the power n by 2 into cos of n pi by 4 minus iota sine of n pi by 4. Very fine. Let's add these two. 1 plus iota the power n plus 1 minus iota the power n equals to 2 the power n by 2 into cos of n pi by 4 plus iota sine of n pi by 4 plus 2 the power n by 2 into cos of n pi by 4 minus iota sine of n pi by 4. Taking this 2 the power n by 2 outside, I take this as common, and these two cancelled out and we get 2 into cos of n pi by 4. Adding the powers of 2, this is n by 2 plus 1 and cos of n pi by 4. So we have found this left hand side to be equal to the required right hand side, right? This is what is needed to be proved. So okay, thank you. Be blessed.